The trapper's cabin hung suspended between two cliff faces like a wooden spider web stretched across empty space. And when the blizzard struck with winds strong enough to flatten trees, neighbors waited for the structure to collapse into the canyon below. But through the howling storm, smoke rose steadily from the chimney, and warm light glowed in the windows of a cabin that physics said should be freezing. Before we begin, let us know in the comments where you're watching from, and if stories of forgotten frontier ingenuity move you, subscribe, because tomorrow's tale might be the most impossible survival innovation you've ever heard. The body was still warm when Lars Halverson found it. Duncan MacLeod sat upright against the cabin wall, wrapped in every blanket they owned, his rifle across his lap as if he had been keeping watch. The fire in the stone hearth still burned. Lars had fed it himself 3 hours earlier before stepping outside to check the weather. He had been gone less than 20 minutes. When he returned, Duncan was dead. Lars knelt beside his partner and pressed 2 fingers against Duncan's neck, knowing already what he would find. No pulse. The skin was cooling rapidly in the January air of 1839, but the man had died recently. Very recently. Lars looked at the fire. It crackled and popped, throwing heat into the small cabin. The flames were strong, the wood was dry. Everything was as it should be, except that a healthy man in his 30s had frozen to death less than 10 feet from an active fire. Lars stood slowly and walked to the door. He opened it and looked outside. The Wyoming morning was brutally cold, but not exceptional by mountain standards. Perhaps 20 degrees below zero. Clear skies, light wind. They had survived far worse nights in this cabin. Duncan had survived far worse nights. The man was a veteran trapper with 6 years in the mountains. He understood cold, he understood fire, he understood survival, yet he had died anyway. Lars closed the door and returned to the body. He noticed details now that shock had initially hidden. Duncan's lips were blue, his fingernails were purple. His face held an expression not of pain, but of resignation, as if he had known what was happening and had simply accepted it. Lars touched the blankets wrapped around Duncan's torso. They were thick wool, traded from a supply train the previous autumn. Good quality, well made. They should have been enough. But they were not enough, just as the fire was not enough, just as the cabin itself was not enough. Lars had built this structure with Duncan 2 years earlier when they had first established their trap lines along the Green River. They had followed standard methods, logs notched at the corners and stacked to form walls, mud and moss chinked between the gaps, a stone fireplace built into one corner, a heavy wooden door, one small window covered with oiled paper. The cabin was 18 feet long and 14 feet wide with a peaked roof covered in split shingles. It had taken them 5 days to build. Every trapper in the region built cabins exactly the same way. Lars walked to the fireplace and held his hand near the flames. The heat was substantial, strong enough to warm his palm from 2 feet away. He turned and looked at where Duncan's body sat against the far wall. The distance was perhaps 12 feet between life-sustaining heat and death by freezing. Something was fundamentally wrong with how mountain men built their shelters, and until this morning, Lars had never questioned it. Now his partner was dead, and the question consumed him entirely. Lars spent the rest of that day preparing Duncan's body and digging a grave in frozen ground. He worked mechanically, his mind elsewhere. The question that had seized him in the cabin would not release its grip. How does a man freeze to death 10 feet from a fire? The question seemed simple, but the more Lars considered it, the more complex it became. He buried Duncan on a hillside overlooking their trap lines. The ceremony was brief. Lars was not a religious man, and Duncan had never expressed interest in formal services. When the last stone was placed on the grave, Lars returned to the cabin and began a methodical investigation of the structure itself. He approached it as he would approach tracking an animal, looking for signs that told a story. The first thing he noticed was the snow. It had drifted against the north wall of the cabin, piling up to a height of nearly 3 feet. The snow was packed tight against the logs, creating an insulating barrier that extended along the entire length of that wall. Most trappers would consider this beneficial. Snow was insulation. It should help keep the cabin warm. But Lars knelt and examined the interior wall corresponding to where the snow had drifted outside. He placed his palm against the logs. They were cold, not cool. Cold. The interior surface of the wall felt barely warmer than the exterior. He moved to the south wall where no snow had accumulated. The wind came primarily from the north during winter, so the south wall remained clear. Lars placed his palm against these logs. They were noticeably warmer than the north wall logs. The difference was significant. He could feel it immediately. The south wall was absorbing heat from the fire and retaining some of that warmth. The north wall was not. The snow outside was pulling heat through the logs, creating a thermal drain that no amount of fire could overcome. Lars examined the gaps between logs next. He had chinked them carefully 2 years ago, packing moss and mud into every visible space. But now, with snow pressed against the exterior and warmth inside, he could feel air movement. Cold air was seeping through invisible gaps that the chinking had failed to seal completely. He wetted his finger and held it near the base of the north wall. The moisture evaporated quickly, pulled by the draft of cold air flowing inward at floor level. He looked up at the ceiling. Heat rises. That was common knowledge. But where did it go after it rose? Lars climbed onto the table and examined the roof joints. More gaps, more places where chinking had dried and cracked. Warm air was escaping through the roof while cold air entered at the base. The cabin was functioning as a chimney, constantly cycling warm air out and replacing it with cold air. The fire was fighting a battle it could not win. Lars spent that night feeding the fire constantly and monitoring the interior temperature. He had no thermometer, but he used his body as an instrument. By morning, Lars understood the scope of the problem. Mountain cabins were fundamentally flawed in ways that most trappers never recognized because most trappers survived. They suffered through cold nights and burned excessive firewood and accepted discomfort as the price of mountain life. But some did not survive. Some died like Duncan, freezing, despite their best efforts. The difference between survival and death was a matter of degrees, sometimes literally. A few degrees of temperature could mean everything. Lars made a decision that morning that would consume the next 8 months of his life. He would understand exactly why cabins failed, and he would find a way to build one that did not fail. Other trappers might accept the limitations of standard construction. Lars would not. He could not. Every time he looked at Duncan's grave on the hillside, he felt the weight of preventable death. He began by visiting every trapper camp within 3 days. Travel of his location. He told people he was checking on neighbors after the cold snap, which was partially true. But his real purpose was to examine their cabins. He looked at construction techniques. He measured snow accumulation patterns. He asked questions about how much firewood they burned and where they felt coldest inside their structures. Most trappers thought his questions were odd, but answered them anyway. Mountain culture valued self-reliance, but it also valued shared knowledge that kept people alive. Lars discovered patterns. Cabins built in low areas where cold air pooled were consistently colder inside than cabins built on higher ground. Cabins with north-facing doors were colder than cabins with south-facing doors. Cabins surrounded by trees that blocked wind were warmer than cabins in open areas. But even the warmest cabins he visited had the same fundamental problems: snow banking against walls, air leaks at floor level, heat escaping through roofs. Every cabin was fighting the same losing battle against basic physics. He found 2 abandoned cabins where trappers had died in previous winters. One had partially collapsed. The other was intact but showed signs of desperate last efforts. Blankets had been stuffed into gaps between logs. Additional mud had been applied to the exterior chinking. A second fire pit had been dug in the center of the dirt floor. None of it had been enough. Lars studied these structures carefully, treating them as lessons written in wood and stone. By early February, Lars had examined 19 different cabins and spoken with 23 trappers. He had filled a small notebook with observations written in careful block letters: snow patterns, wind directions, construction details, firewood consumption rates, death locations. He approached the problem with the methodical attention he had previously reserved for reading animal tracks and planning trap lines. His partners would have called him obsessed. They would have been correct. Lars stopped trapping in February of 1839. The beaver season continued, but he ignored his trap lines. Other trappers noticed, and word spread that Duncan MacLeod's death had broken Lars Halverson's mind. Some men responded to trauma by drinking themselves senseless, others by abandoning the mountains entirely. Lars responded by sitting motionless for hours in the snow, watching how wind moved across the landscape. He chose observation points carefully: hilltops where he could see weather patterns developing from miles away, valley floors where cold air pooled and created frost pockets, ridge lines where wind accelerated and created visible snow plumes. He was studying invisible forces that shaped temperature and survival. Wind was not just cold air moving. It was a physical force that pushed and pulled and redirected. It had patterns. It had behaviors. Lars noticed that wind did not flow smoothly across uneven terrain. It tumbled and swirled. When it encountered obstacles like hills or rock outcroppings, it created turbulence. The turbulent air mixed warm and cold layers, making some areas paradoxically warmer than others. He found spots sheltered behind boulders where temperature was noticeably higher than surrounding areas, not because the rock provided heat, but because it created dead air space that wind could not penetrate. He observed how wind interacted with structures. When wind hit a solid wall, it did not simply stop. It pressed against the surface with force proportional to its speed, and it created pressure that drove cold air into every gap and crack. A cabin wall facing into wind was under constant assault, not just from cold, but from pressure that forced cold air through imperfections in construction. The cabin became like a sail, with wind driving cold through one side and pulling warm air out the other. But Lars also noticed places where wind behaved differently. There were narrow canyons in the mountains where wind funneled through the gap rather than swirling around obstacles. He found one such canyon about 5 miles from his current cabin while tracking an elk in late February. The canyon was perhaps 30 feet wide and dropped 60 feet to a rocky bottom. On a day when surface wind was moderate, the wind through the canyon was fierce, compressed, and accelerated by the narrowing walls. Lars climbed down into the canyon using handholds in the rock face. At the bottom, the wind howled overhead like a living thing. But where Lars stood, protected by the canyon walls, the air was almost still. More importantly, it was noticeably warmer than the exposed ridge above. The temperature difference was perhaps 10 degrees. He stayed in the canyon for an hour, moving along its length and feeling how temperature varied. The canyon ran roughly east to west. Wind typically came from the north or northwest during winter storms. When Lars positioned himself on the north side of the canyon with his back against the rock wall, wind passed completely overhead without touching him. Lars returned to the canyon repeatedly over the next 2 weeks. He brought blankets and spent entire days sitting against the north wall, observing and measuring with his body what instruments could not tell him. Other trappers would have considered this madness, a man sitting in a canyon doing nothing, while beaver pelts went uncollected. But Lars was working harder than he had ever worked, solving a problem that had killed his partner and would kill others if left unsolved. He began to understand the canyon as a system. Cold wind entered from the west, where the gap opened onto a broader valley. The narrowing walls compressed the wind and accelerated it, creating a river of fast-moving air that flowed through the canyon at a consistent height. That height was approximately 40 feet above the canyon floor. Below that elevation, the air was relatively calm. The wind passed over rather than through the lower canyon space. Lars tested this observation by building small fires at different heights along the canyon wall. A fire built on the canyon floor burned steadily with minimal disturbance. A fire built on a ledge 20 feet up showed moderate flame movement. A fire built on a ledge 35 feet up was nearly extinguished by wind. The stratification was clear. There was a boundary layer where wind transitioned from calm to violent, and that boundary was consistent regardless of overall wind speed. He noticed something else equally important. Snow did not accumulate on the canyon floor in the same patterns it accumulated on open ground. On flat terrain, snow drifted and piled against any obstacle, creating the same banking effect he had observed against cabin walls. But in the canyon, wind moving overhead at high speed created a Venturi effect that actually pulled snow upward and carried it out of the canyon entirely. The floor remained relatively clear even after significant snowfall. Lars climbed back to the canyon rim and examined the rock formations on both sides. The walls were solid granite, weathered but stable. The canyon had existed for thousands of years and would exist for thousands more. The rock faces showed no signs of crumbling or instability. On both the north and south rims, there were flat areas extending back from the edge, suitable for anchoring structures. He paced the canyon width, 32 feet from the north rim to the south rim at the narrowest point. Wider in some places, narrower in others. But there was a section approximately 60 feet long where the width remained constant at 30 to 35 feet. The canyon floor at this section was roughly 50 feet below the rim, deep enough that wind would pass well below anything built at rim level. Lars sat at the canyon edge and watched the sun set behind the western mountains. Wind continued flowing through the gap, constant and predictable. He thought about Duncan freezing 10 feet from a fire. He thought about snow banking against cabin walls and cold air seeping through gaps and heat escaping through roofs. Then he thought about a cabin built not on the ground but spanning this canyon, suspended in the calm air below the wind layer. The idea seemed insane even to Lars, and he was the one thinking it. Build a cabin across a canyon. Not near a canyon or overlooking a canyon, but literally spanning the gap with nothing but air beneath it. Every instinct developed through 6 years of mountain survival told him this was suicidal. Exposed locations were dangerous. Height meant wind exposure. Bridges were temporary crossing structures, not places to live. Yet the more he considered the physics, the more sense it made. A ground-level cabin fought constant battles. Snow banked against walls and pulled heat through logs. Cold air pooled at the base and seeped inside. Wind hit walls directly and drove cold through every imperfection. Moisture from ground contact rotted lower logs and created thermal bridges. Every problem Lars had identified over the past 2 months stemmed from ground contact and wind exposure at ground level. A cabin spanning this canyon would eliminate every one of those problems. No ground contact meant no snowbanking. No ground moisture meant no rot. Wind would pass beneath the structure rather than against it, eliminating direct pressure on walls. Cold air would fall through the canyon instead of pooling around the cabin base. The structure would sit in relatively calm air, protected by the canyon walls from the worst wind while remaining above the cold air drainage. Lars understood the challenges. He would need to span 32 feet of empty space with enough structural strength to support a complete log cabin plus snow load on the roof. He would need to anchor the support system into solid rock on both sides. He would need to build the entire structure alone because no other trapper would help with something this insane. He would need to transport materials to a location with difficult access. The project would take months and consume the entire trapping season. But if it worked, he would have a cabin that stayed warm with minimal firewood. A cabin that would last decades without major maintenance. A cabin that would prove Duncan's death had not been inevitable, but preventable. That last point mattered more than Lars wanted to admit. He could not bring Duncan back, but he could ensure future trappers did not die the same way. He spent 3 days sketching plans using a piece of charcoal on flat pieces of bark. He had no formal engineering training, but he understood leverage and weight distribution from years of rigging trap sets and hauling heavy loads. A cabin was essentially a box that needed support at multiple points. If he could create a strong platform spanning the canyon, the cabin itself would be straightforward. The support structure was the critical element. Lars envisioned large beams extending from rock anchors on both rims, meeting in the middle to create a framework. Cross beams would connect the main supports and distribute weight. The entire assembly would function like a bridge deck with the cabin built on top. Lars chose his building site in early March of 1839. The location was 7 miles from his current cabin, accessible by a difficult trail that climbed through dense pine forest before emerging onto the canyon rim. The spot met specific criteria Lars had developed through weeks of observation. The canyon ran east to west, meaning prevailing winter winds from the northwest would flow through the gap efficiently. The rim on both sides was solid granite, extending back at least 20 feet from the edge, providing stable anchor points. The canyon width at this location was 32 feet, narrow enough to span but wide enough that wind compression created the protective effect Lars wanted. The flat area on the north rim was larger, approximately 40 feet deep before the ground sloped upward into hillside. Lars would build the majority of his working space on this side. The south rim was less accommodating, only about 15 feet of flat ground before steep terrain, but sufficient for anchoring the support structure. The canyon floor below was rocky and uneven, dropping 55 feet from rim level. Not the deepest section Lars had found, but deep enough that wind would pass well beneath the cabin floor. Water access was manageable. A small creek ran through pine forest 200 yards north of the canyon rim. The distance was inconvenient but acceptable. Lars would need to haul water daily, but he had hauled water farther in previous camps. The creek flowed year-round, fed by snowmelt in springs higher in the mountains. More importantly, the creek was uphill from the cabin site, meaning Lars would not need to climb after fetching water. Timber availability was excellent. The pine forest surrounding the area provided straight trees of appropriate diameter for both structural beams and cabin logs. Lars would need to be selective, but the resource was abundant. He estimated he could harvest everything necessary within half a mile of the building site, minimizing transportation distances. The trees grew on relatively flat ground, making felling and limbing easier than in steep terrain. The location was remote enough to discourage casual visitors, but accessible enough for Lars to bring supplies. The nearest occupied trapper cabin belonged to Elias Mercer, about 9 miles east. Elias was a solitary man who kept to himself, which suited Lars perfectly. He wanted no audience during construction and no interference from well-meaning trappers trying to talk him out of his plans. Lars spent 2 full days clearing the north rim area of brush and small trees, creating a work zone where he could process timber and fabricate components. He established a temporary camp with a simple lean-to shelter and fire pit. He would live here during construction, visiting his main cabin only to retrieve supplies. The lean-to was adequate for sleeping. He did not need comfort. He needed focus. He marked anchor points on both canyon rims using stakes driven into cracks in the rock. The marks indicated where his main support beams would rest. 4 anchor points on each side, 8 total, creating a distributed load system. Lars began the foundation work in mid-March when the ground was still frozen, but days were growing longer. The first challenge was creating secure anchor points in solid granite. He could not simply rest beams on the rock surface and expect them to hold under the weight of a complete cabin. The beams needed to be locked into the stone itself, becoming extensions of the mountain rather than objects sitting on top of it. He started by identifying natural features in the rock that could serve as anchor points. Cracks, crevices, and depressions already existed in the granite from centuries of weathering. Lars examined every inch of rim rock on both sides of the canyon, looking for formations that could be enhanced and utilized. He found 4 promising locations on the north rim and 4 on the south rim, spaced to distribute the cabin's weight evenly across the span. The work was brutally slow. Lars used a hand drill, a heavy iron tool with a cutting bit that required constant rotation and pressure. He drilled into existing cracks, enlarging them to accept wooden anchor pins. Each hole needed to be at least 18 inches deep and 4 inches in diameter. Drilling one hole took an entire day of continuous work. His hands blistered and bled. His shoulders ached from the repetitive motion. But the holes progressed, fraction of an inch at a time. He made anchor pins from oak, the hardest wood available in the region. He had traded for oak planks in St. Louis 2 years earlier, intending to use them for furniture. Now they served a more critical purpose. Lars shaped each pin with careful attention, creating a tapered form that would wedge tightly into the drilled holes. The pins were 2 feet long and as thick as his forearm at the base, tapering to 3 inches at the top. He coated each pin with pine resin before driving it into the rock. The resin served multiple purposes. It filled microscopic gaps between wood and stone, creating a tighter fit. It acted as waterproofing to prevent moisture from rotting the wood. And once it hardened, it essentially glued the pin into place. Lars heated the resin until it was liquid, poured it into the holes, then drove the pins home with a heavy maul. The pins seated with solid, reassuring thuds that indicated they had bottomed out properly. After the resin cured for 3 days, Lars tested each pin by attaching ropes and applying as much pulling force as his body weight could generate. The pins did not move. They were effectively part of the rock now. He had created 8 anchor points that could support enormous loads without failing. This foundation system was unprecedented in frontier construction. Most mountain men simply stacked stones or set posts in shallow holes. Lars had engineered something that would last centuries. With the anchor points established, Lars began fabricating the main support beams. He selected 4 pine trees, each approximately 2 feet in diameter and 60 feet tall. The trees needed to be straight with minimal taper and no significant defects. He found what he needed within 300 yards of the building site. Elias Mercer arrived at the canyon site on a morning in early April. Lars heard him coming through the forest, making no attempt at stealth. Elias rode a mule loaded with supplies and led a second mule carrying beaver pelts. He was heading to the spring rendezvous, the annual gathering where trappers sold their furs and resupplied. He had detoured to check on Lars after hearing rumors that Duncan's partner had gone mad and abandoned his trap lines. Elias dismounted at the north rim and stood staring at what Lars had built so far. The 8 anchor pins protruded from the rock on both canyon sides. 4 massive pine logs lay on the north rim, stripped of bark and shaped to precise dimensions. Rope and pulley systems hung from trees near the canyon edge. The work area showed evidence of intense, focused labor. But the location made no sense to Elias or any rational person. "You building a bridge?" Elias asked. His tone was careful, the voice of someone talking to an unstable individual. Lars continued working on the beam he was shaping, using a draw knife to smooth the surface. He did not look up. "A cabin?" he said simply. Elias was silent for a long moment. Then he laughed. It was not cruel laughter, but the reflexive response of someone confronted with absurdity. "A cabin," Elias repeated. "Across a canyon." He walked to the edge and looked down, with 50 feet of empty air underneath. Lars set down his draw knife and faced Elias. "Wind passes under, not through the walls. No snowbanks against the base. Cold air falls instead of pooling. The cabin will stay warmer with less firewood." He spoke in the same tone he might use to explain a trap set, describing practical mechanics rather than defending a questionable decision. Elias shook his head slowly. Lars, you've been up here too long alone. Duncan's death was hard. No, but this, he gestured at the canyon, this is suicide. First strong wind will blow the whole thing into the rocks below. Wind flows through the canyon at 40 feet elevation, Lars said. The cabin floor will be at 15 feet, below the wind layer. Elias stared at him. You've measured wind layers in a canyon. It was a statement, not a question, delivered with the concern of someone realizing a friend had genuinely lost his mind. I have, Lars confirmed. For 6 weeks. Elias mounted his mule without another word. Before leaving, he turned back. There's still time to come to rendezvous. Sell your furs. Get out of these mountains for a while. Come back when your head's clear. My head is clear, Lars said. Clearer than it's been in years. Elias rode away shaking his head. Lars returned to his beamwork. Over the next month, 3 more trappers visited the site. Word had spread through the scattered mountain community that Lars Halverson was building something insane near Skull Canyon. The name was not official, just what trappers called this particular gap in the rocks because a boulder at the east end supposedly resembled a skull. The main beams were ready by late April. Each was 40 feet long, stripped smooth, and tapered slightly from 2 feet in diameter at the base to 20 inches at the far end. Lars had spent 3 weeks shaping them with obsessive precision. They needed to be as uniform as possible to distribute weight evenly. Any significant imbalance would create stress points that could fail under load. The challenge now was getting the beams across the canyon. Lars could not simply push them out from one rim and hope they reached the other side. The span was too great, and the beams would tilt and fall before making contact with the opposite rim. He needed a different approach, one that involved careful engineering and substantial risk. He built a temporary support structure on the north rim using smaller logs set in a triangular brace pattern. This structure extended 6 feet beyond the canyon edge, creating a launching platform. Lars also rigged a rope and pulley system anchored to trees 30 feet back from the rim. The ropes would control the beam's descent angle as it was pushed across the gap. On the south rim, he had already installed a similar pulley system that could pull the beam once it extended far enough across the canyon. The entire operation required coordinating forces from both sides simultaneously. He waited for a calm day. Wind made the operation impossible. Even moderate gusts could catch the beam once it extended into open air and twist it out of control. On April 28th, dawn arrived with perfectly still air. Lars began immediately, knowing conditions could change within hours. He positioned the first beam on his launching structure, secured control ropes, and began the push. The beam slid forward slowly, extending into empty space. Gravity wanted to rotate it downward. Lars controlled this rotation with the rope system, feeding out line carefully to maintain the correct angle. When the beam extended 20 feet beyond the north rim, he signaled to himself he was working alone and adjusted the south side ropes. He had pre-rigged these ropes the previous day, running them across the canyon using a lighter line and pulley. The beam continued forward, now 30 feet extended, 12 feet of length remaining on the north rim. It was nearing the critical balance point where weight would shift from the north rim to the south rim. Lars adjusted rope tension constantly, reading the beam's behavior through the vibrations transmitted up the control lines. When the beam reached the south rim, Lars secured the north side ropes and crossed the canyon using a rope bridge he had installed weeks earlier. On the south rim, he pulled the beam into position and secured it to 2 of the anchor pins. The beam now spanned the entire canyon, locked at both ends, suspended over empty air. Lars stood at the south rim and looked across at his work. 1 beam in place, 3 more to go. With the platform complete, Lars began construction of the cabin itself in early June. The foundation was a suspended deck 32 feet long and 18 feet wide, solid enough to support multiple tons of weight. Now came the familiar work of log cabin construction, though nothing about this project felt familiar. Building walls on a platform suspended 50 feet above a rocky canyon floor introduced complications that standard ground-level construction never faced. Lars started by selecting logs for the walls. He needed 40 logs total, each 16 feet long and approximately 12 inches in diameter. He chose pine for its straightness and workability, rejecting any log with significant taper, large knots, or visible defects. Each log would be stripped of bark, shaped to consistent diameter, and fitted carefully to minimize gaps. The process was identical to how he and Duncan had built their first cabin, but Lars now understood that careful fitting was not merely aesthetic preference. It was survival engineering. He felled the trees individually, limbed them on site, and hauled them to the canyon rim using a mule he had borrowed from a trapper 20 miles south. The trapper had accepted Lars's last season of beaver pelts as collateral, clearly expecting never to see Lars alive again to reclaim them. The mule made transportation manageable. Without it, Lars could not have moved 40 logs of this size to the remote location. Each log needed to cross the canyon to reach the building platform. Lars had refined his rope and pulley technique during platform construction, and moving individual logs was now routine, though still dangerous. He secured each log with multiple rope wraps, extended it across the gap using the pulley system, and lowered it onto the platform where he could work. The process took approximately 2 hours per log. By mid-June, all pisa. 40 logs rested on the suspended platform. Lars began raising the walls using traditional notched corner construction. He had considered alternative methods, but recognized that standard notching, properly executed, provided adequate strength. His innovation was not in corner joints, but in overall design philosophy. The walls went up in pairs, opposite sides built simultaneously to maintain balance on the platform. North and south walls first, then east and west walls, each course of logs lifting the structure higher. He fitted each log with obsessive care, using his draw knife to shape contact surfaces until gaps were minimal. Between logs, he packed a mixture he had developed specifically for this cabin. Traditional moss and mud chinking would fail in this exposed location. Lars created a compound using clay from the creek bank, mixed with pine resin he had harvested and boiled down, and reinforced with deer hair from hides he had processed. The mixture was waterproof, flexible, and far stronger than standard chinking. The walls rose slowly through June and into July. Lars worked alone, lifting logs into place using a lever system he had rigged from smaller poles. Each log weighed between 150 and 200 pounds. Positioning them accurately required strength, patience, and careful mechanical advantage. By late July, the walls stood 7 feet tall, creating an enclosed space that finally resembled a cabin rather than an experimental platform. The roof construction began in August. Lars had delayed this phase deliberately, wanting the walls fully settled and chinked before adding the substantial weight of a complete roof system. The roof would be the heaviest single component of the cabin, and it needed to be engineered for snow loads that could exceed 2,000 pounds during severe winters. Standard cabin roofs often collapsed under heavy snow. Lars's roof would not. He started with ridge beams, massive logs that would span the 18-foot width of the cabin and support all other roof components. He selected 3 ridge beams, each 14 inches in diameter and 20 feet long. The extra length allowed the roof to overhang the walls by 12 inches on each end, creating protection from rain and snow. Lars positioned these beams across the top of the walls, spacing them evenly and notching them to sit securely on the uppermost wall logs. Across the ridge beams, Lars laid split planks. He had spent 2 weeks splitting straight-grained pine into planks approximately 3 inches thick and 8 inches wide. Each plank was shaped flat on one side using his draw knife, creating smooth surfaces that would fit tightly together. He laid these planks with overlap, each course covering gaps in the course below, creating a shingle effect that would shed water efficiently. The planks were pegged to the ridge beams using wooden pins whittled from oak. Over the planks, Lars applied multiple layers of birch bark. He had harvested the bark in spring when it peeled most easily from trees, storing it flat under weights to prevent curling. Birch bark was naturally waterproof and flexible, superior to any other material available in the mountains. He laid the bark in overlapping sheets, creating a continuous membrane across the entire roof surface. Over the bark, he spread his clay resin mixture, the same compound he had used for wall chinking, but applied thicker here. The layer was approximately half an inch thick when completed, sealing every potential leak point. The final roof layer was living sod. Lars cut sections of grass and soil from the meadow near his creek, transporting them to the cabin in sections approximately 1 foot square. He laid these across the entire roof, grass side up, creating a living roof that would root and grow. The sod added significant weight, but it also provided insulation, fire resistance from sparks, and additional waterproofing. The multiple-layer roof system was far more complex than standard construction, but it was also genuinely weatherproof. The chimney required special attention. Lars built it from flat stones gathered from the canyon floor, accessed by climbing down rope ladders. He selected stones that fit together with minimal gaps, creating a structure that was both stable and efficient. The chimney extended from a stone fireplace built into the cabin's northeast corner, rising through the roof and extending 4 feet above the peak. Lars made the chimney narrow, only 8 inches square internally, too small for anything to climb down, but adequate for smoke passage. Lars completed the cabin in late September of 1839. The structure had consumed 6 months of continuous work, representing more labor than any trapper typically invested in shelter. He moved his supplies into the finished cabin on a clear afternoon when autumn colors were reaching peak intensity across the surrounding mountains. The interior was simple but functional, one room measuring 16 feet by 14 feet, a stone fireplace in the corner, a sleeping platform built along one wall, shelves for supplies, a small table and single chair, nothing elaborate. Everything necessary. He stood at the cabin's single window and looked across the canyon at the north rim where his journey had begun. From inside, the sensation of suspension was profound. The floor felt solid, but the view revealed only empty space in every direction except where walls blocked sight lines. Wind moved through the canyon below, audible but not felt. The cabin remained remarkably still despite its exposed position. Lars had built something that appeared to defy logic, but actually exploited physics most people never considered. Word of the completed cabin spread quickly through the trapping community. The structure was too unusual to ignore, and trappers traveling through the region detoured to see what Lars Halvorsen had actually accomplished. Most arrived expecting to find a crude, unstable shelter that would barely survive its first storm. What they found instead was a solidly built log cabin that happened to span a canyon. The craftsmanship was evident, the engineering was sound, but the location still seemed suicidal to anyone with mountain experience. Thomas Ashford visited in early October. Thomas was a veteran trapper with 12 years in the Rockies, respected throughout the region for his practical knowledge and survival skills. He examined the cabin thoroughly, walking the platform perimeter, testing structural connections, studying the anchor points. Lars showed him everything without defensiveness, explaining his reasoning for each design choice. Thomas listened, asked technical questions, and said little. Before leaving, he offered one comment. "It's well built, I'll grant you that. But you won't survive winter up here. Too exposed. Wind will freeze you out, even if the structure holds." Silas Crane arrived a week later with similar predictions. Silas was younger, only 4 years in the mountains, but he voiced what most trappers believed. "You've wasted 6 months building a fancy coffin. First blizzard will prove it." Lars did not argue with any of them. He simply continued his preparations for winter. He had learned that defending ideas was pointless. Results would speak for themselves. He stockpiled firewood throughout October, cutting and splitting pine and storing it inside the cabin where it would stay dry. He estimated he needed half the wood a ground-level cabin would require based on his calculations of heat retention. If his calculations were wrong, he had made no backup plan. He organized his food supplies, primarily dried meat and beans, stored in barrels to protect from rodents. The first significant storm arrived in early November. Lars woke before dawn to the sound of wind building across the mountains. The noise was different from summer winds, carrying a deeper tone that indicated serious weather developing. He dressed and went to the window. Gray clouds moved rapidly from the northwest, and the air temperature had dropped noticeably overnight. Snow was coming, possibly substantial amounts based on cloud formation and wind direction. By mid-morning, snow was falling heavily. Wind had increased to the point where visibility dropped to less than 50 yards. Lars fed his fire and settled in to wait. This was the test everyone had predicted would destroy his cabin. Other trappers would be inside their ground-level structures, feeding fires constantly, fighting drafts, and hoping their roofs held under snow accumulation. Lars wanted to know if his 6 months of work had been brilliant engineering or elaborate suicide. The wind noise was impressive, not inside the cabin, but outside and below. Lars could hear wind roaring through the canyon beneath the floor, a constant rushing sound like a river in flood. But inside the cabin, air movement was minimal. He wet his finger and held it near the base of the walls. Almost no draft. The careful chinking was holding. Heat from the fire was not being pulled outside by infiltrating cold air. He monitored the fire carefully throughout the day. Standard practice in a winter storm was to feed fires continuously, piling on wood to combat the cold air that ground-level cabins could not exclude. Lars fed his fire moderately, maintaining steady flames, but not building the massive blazes that consumed firewood at unsustainable rates. By afternoon, the interior temperature felt comfortable, not warm by summer standards, but far warmer than he had expected given the severity of the storm outside. Snow accumulated on the roof throughout the day, and into evening. Lars could hear the weight increasing, a subtle creaking in the ridge beams as load built up. He had engineered for this, but engineering theory and real-world performance were different things. If his calculations were wrong, the roof would fail spectacularly, probably collapsing inward and taking the walls with it. He would have no warning and no escape route. By nightfall, the storm had intensified. Wind through the canyon had reached the point where Lars felt occasional vibrations in the floor, transmitted through the support structure from wind pressure on the anchor points. The vibrations were slight but noticeable, reminding him that his cabin was not resting on solid ground, but suspended over empty space by engineering he had designed alone with no formal training. If the structure failed, the failure would be total and immediate. He slept poorly that night despite exhaustion. Every unusual sound brought him awake, listening for cracking wood or shifting beams. But the sounds never came. The cabin held. Morning arrived with continued snow but diminishing wind. Lars went outside onto the platform and examined the structure. Snow had drifted on the roof to depths of approximately 18 inches. The ridge beams showed no sagging. The walls remained plumb. Everything had held perfectly. The storm that would validate or destroy Lars's design arrived in late January of 1840. Weather had been moderate through December and early January, cold but manageable. Then atmospheric conditions shifted in ways that old-timers recognized as precursors to serious events. The air became unnaturally still. Clouds built slowly from the north. Temperature dropped steadily over 3 days. Trappers throughout the region prepared for the worst, and their preparations proved inadequate. The blizzard struck on January 24th with wind speeds Lars estimated exceeded 60 miles per hour on exposed ridges. Snow fell so heavily that visibility dropped to zero. The storm was not a typical mountain weather event, but a genuine survival crisis. Lars learned later that 2 trappers died during this storm, both in supposedly well-built cabins that failed under conditions their construction could not withstand. Inside his suspended cabin, Lars experienced the storm very differently than trappers in ground-level structures. Wind noise was tremendous, but it came from below and around, rather than directly against the walls. He could hear wind roaring through the canyon like an avalanche, compressed by the narrowing walls and accelerated to incredible speeds. That wind passed completely beneath his floor, never striking the cabin walls with full force. The temperature differential was dramatic. Lars had no thermometer, but he estimated exterior temperature was at least 30 degrees below zero, possibly colder with wind chill factored in. Inside the cabin, with a moderate fire burning, temperature remained above freezing. He wore a single layer of wool clothing and felt comfortable. In a ground-level cabin with the same fire, he would have needed every piece of clothing he owned and still felt cold. Snow accumulation on the roof reached extreme levels. Lars estimated 3 feet of snow by the second day of the storm. The weight was enormous, probably exceeding 3,000 pounds across the entire roof surface. But the ridge beams held without visible sagging. His engineering had been conservative enough to handle even this extreme loading. The multiple-layer roof system also proved its worth. Despite hurricane-force winds and driving snow, not a single leak developed. The interior remained completely dry. The most remarkable observation came on the 3rd day of the storm. Lars went outside during a brief lull in snowfall and examined the cabin's foundation level. On a ground-level cabin, snow would have drifted against the walls to depths of 4 or 5 feet, creating massive insulation that actually pulled heat from the structure through the logs. On Lars's suspended cabin, snow had not accumulated at the base of the walls at all. Wind through the canyon had created the ventry effect he had predicted, actually pulling snow away from the structure rather than allowing it to bank. The lower 3 feet of his walls remained completely exposed. By the 4th day, the storm began breaking up. Wind diminished, and snow tapered off. Lars had burned approximately half the firewood he estimated a ground-level cabin would have required for the same period. When the storm cleared on January 28th, Lars emerged from his cabin to find a landscape transformed by snow depths rarely seen even in the high Rockies. Drifts exceeded 6 feet in many locations. Travel would be impossible for days, possibly weeks, until either wind scoured paths or warmer weather consolidated the snow. Lars was not concerned about isolation. He had supplies for months and no pressing need to go anywhere. What concerned him was the silence from neighboring trappers. He learned the full scope of the storm's damage 3 weeks later, when Elias Mercer appeared at the canyon rim traveling on snowshoes and leading no mules. Elias looked exhausted and much thinner than Lars remembered. He stood at the north rim, staring at the cabin that still stood suspended over the canyon, completely intact, with smoke rising from its chimney. His expression showed something between disbelief and accusation, as if Lars had somehow cheated by surviving what should have been unsurvivable. Lars crossed to the north rim, using the rope bridge he kept installed during winter. Elias spoke before Lars could ask questions. "Michael Sutton's dead. His cabin collapsed under the snow load on the 2nd night. Roof came down and trapped him inside. We found his body a week ago when we could finally dig out. Michael had been a competent trapper, careful and experienced. His cabin had been well built by standard methods. It had not been enough. Thomas Langford's dead too," Elias continued. "He didn't freeze exactly. His cabin held up, but he burned through all his firewood by the 3rd day trying to stay warm. Tried to make it to another camp for more wood. We found him 200 yards from his cabin. He almost made it." Elias looked at Lars's cabin again. "How much firewood did you burn?" The question carried weight beyond simple curiosity. Lars considered lying or deflecting, but saw no point. "About 40% of what I stored for a storm that length." Elias was quiet for a long moment. "I burned everything I had. Every piece of wood in my cabin plus furniture I broke up for fuel. I was still cold enough that I couldn't sleep more than an hour at a time. My cabin's built solid, double-chinked. But it wasn't enough." He paused. "You stayed warm." It was a statement, not a question. Lars nodded. "The wind passes underneath. It doesn't hit the walls directly. That makes all the difference." Over the next month, 7 different trappers visited Lars's cabin. Word had spread that he had not only survived the blizzard, but had done so comfortably in a structure everyone had predicted would fail. They came skeptical, expecting to find exaggeration or luck. What they found was undeniable physical evidence: a suspended cabin that showed no weather damage, a modest woodpile that should have been depleted but was not, an interior that was measurably warmer than ground-level cabins despite identical fire sizes. Thomas Ashford arrived at the canyon in early March with questions Lars had expected. Thomas was methodical and intelligent, the kind of man who understood that dismissing evidence because it contradicted expectations was foolish. He examined every aspect of Lars's cabin with careful attention, measuring snow accumulation patterns, testing structural integrity, and observing how wind moved through and around the suspended structure. He spent an entire day making observations before speaking his conclusions. "The wind really does pass under," Thomas said that evening as they sat inside the warm cabin. "I wouldn't have believed it without seeing the snow patterns. Ground-level cabins have 5-foot drifts against the north walls. Your north wall is completely clear. The canyon creates a wind tunnel effect that pulls snow away instead of packing it against the structure." He paused, organizing his thoughts. "The heat retention is remarkable, too. We're sitting comfortably with a fire half the size I'd need in my cabin. There's almost no draft at floor level, no cold air infiltration." Thomas was silent for a moment, staring at the fire. "I lost 2 friends in that blizzard, Michael and Thomas Langford. Both died in cabins that should have protected them, standard construction that every trapper in these mountains uses." His voice carried no accusation, only the weight of understanding that preventable deaths had occurred. "This design you've developed could have saved them. It will save others if people adopt it." Lars had not built his cabin to prove a point or revolutionize frontier construction. He had built it to survive after watching Duncan freeze to death. But Thomas's words made him recognize that the implications extended beyond personal survival. If the suspended canyon design worked as well as the blizzard had proven, other trappers needed to know. Lives depended on sharing knowledge, not hoarding it. "I'll help you build one if you want," Lars offered. "Show you the techniques. The anchor system, the platform construction, all of it." Thomas nodded slowly. "I've got a location that might work. Canyon about 6 miles from my current camp, narrower than this one, maybe 25 feet across. I never considered it for building because the conventional thinking is you need solid ground." He smiled slightly. "Conventional thinking isn't always correct." Over the following 2 months, 3 more trappers approached Lars with similar requests. Word had spread through the mountain community, not as gossip, but as practical information exchange. Trappers talked about techniques that worked and techniques that failed. A cabin that stayed warm with minimal firewood during the worst blizzard in memory was information worth sharing. Lars spent portions of that spring and summer helping other trappers evaluate potential canyon sites and begin their own suspended cabin projects. He did not charge for his assistance or attempt to claim ownership of the design. Frontier culture operated on shared knowledge. A man who discovered a better way to set beaver traps shared that knowledge because next season he might need to learn a better way to tan hides. Lars approached his cabin design the same way. He explained his engineering reasoning, demonstrated his construction techniques, and offered advice based on his experience. What others did with that knowledge was their decision. Lars Halvorsen left the Rocky Mountains in the spring of 1844. The fur trade was collapsing as beaver populations declined and Eastern fashion shifted away from felt hats towards silk. Men who had spent decades in the wilderness were facing economic reality. The mountain man era was ending. Lars sold his remaining supplies and his suspended cabin to a young trapper named Jacob Thorne for $300, a substantial sum that reflected the cabin's proven value. Jacob would live in that cabin for the next 9 years before moving to Oregon Territory. Lars traveled west with a small wagon train, crossed the Continental Divide through South Pass, and eventually settled in the Willamette Valley, where land was available to those willing to work it. He married in 1846 a widow named Catherine Mills, who had lost her husband to illness during the westward journey. They established a farm, raised 3 children, and lived unremarkably quiet lives. Lars never spoke much about his mountain years. When asked, he said he had been a trapper. He did not mention the cabin or the engineering or the innovation that had kept him alive when others had died. But in the mountains he had left behind, his legacy continued in ways he never witnessed. Trappers, hunters, prospectors, and eventually settlers discovered that suspended cabins in appropriate locations provided superior shelter in extreme conditions. The technique spread organically as people shared knowledge and observed results. By the 1850s, there were at least a dozen canyon-spanning cabins scattered through the Rockies from Montana to Colorado. The exact number was unrecorded because frontier construction went largely undocumented. The cabins were never called Halvorsen cabins or given any formal designation. They were simply known as bridge cabins or canyon cabins, descriptive terms that explained their most obvious feature. The builders adapted Lars's principles to their specific locations and available materials. Some spanned wider gaps using additional support beams. Some incorporated stone foundations where canyon walls permitted. Some added features Lars had never considered. The core innovation remained consistent. Suspend the living space above ground level and allow wind to pass beneath rather than attack the structure directly. Modern historians estimate that this design approach saved multiple lives over the following decades. The exact number cannot be determined because survival often goes unrecorded while death generates stories. But accounts from the period include references to trappers and settlers surviving severe winters in well-built cabins that remained warm with reasonable firewood consumption. Some of these accounts almost certainly refer to structures built using principles Lars had developed. Lars Halvorsen died in 1868 at age 53 from pneumonia contracted during an unusually wet winter. He was buried in a small cemetery outside Salem, Oregon. His gravestone identified him as a farmer and family man. There was no mention of his earlier life or his contribution to frontier survival knowledge. His children knew he had been a mountain man before settling in Oregon, but they knew few details. That generation saw the mountains as a rough past, best left behind rather, than a source of pride or legacy. In the mountains themselves, several of the canyon-spanning cabins remained standing into the 20th century.